Okay, so here's step one to figure out if we have one triangle, no triangles, or two triangles, okay? So first we're gonna find the missing angle. So this is the information that was given to me. I have angle A is 30 degrees. I have side A is 5. And I have side B is 12. So that's angle B. So the first step, you wanna find this missing angle. I have a pair here. I have angle A and side A. I have side B, but I don't have angle B. So we need to find angle B. So that's sine B, and it goes over its side. And then I have sine of 30 degrees with its side, 5. So this is the law of sines. Now, we're gonna go ahead and solve for angle B. You're gonna multiply both sides by 12. And let's type that into the calculator. So we got sine of angle B is 1.2. However, this is not possible because if you remember on your unit circle, the highest value on the unit circle was 1. You had numbers like square root of 3 over 2, which is about 0.8. You have numbers like square root of 2 over 2. 1.2 is not on your unit circle. That is not possible. Also, whenever you try to solve for angle B, you have to do the inverse. Whenever you solve for an angle, you always do the inverse. So if you type this into the calculator, it's just gonna say error, or it might say undefined, one of the two. So whenever you get that, you know that there is no triangle. Also, I think this is the example we might have done in the beginning. The height of this triangle is 6, and 5 is shorter than 6. So this triangle would never close. So this answer is no triangle. It's not possible. All right, next example. I'm gonna go ahead and draw it. I'm gonna say that this is 130 degrees, and then side of A is B, and then I'll just call this side B. Okay. So I'm gonna use law of sines. So the first step is to find the missing angle. So I'm missing angle B. So whatever I'm missing, I'm gonna put it in the numerator. Angle B goes with 10, and sine of A is 130 degrees, and that is over its side, which is 8. Okay, so now we're gonna solve. So I'm gonna multiply by 10 on both sides. I got 0.95. So sine of angle B is 0.95756. Okay, so if you want to get the angle and not sine of the angle, you need to do the inverse. So sine inverse, and you get 73.25 degrees. I rounded to the hundredths place. All right, so that means angle B is 73.25 degrees. Now let's look at this triangle. Do you guys know what the angles of a triangle add up to? 180. So is this triangle possible? No, because these two, if you add these two angles together, it's already over 180. So we don't even have space for a third angle. So that means this is no triangle either. This is no triangle as well. So let's review what we just learned. There is no triangle when one, you get the angle and put it in your triangle and it makes no sense because it already surpasses 180. Another possibility is you do law of sines again and you get error because sine of an angle cannot be over 1. It has to be less than 1. So you're gonna get an error notification. Okay, so those are the two ways that you're gonna get no triangle. Okay, let's do the next example. I'm gonna go ahead and draw this. So I'm gonna say angle A is 50 degrees, 16, this is B, this is 10. As long as angle A is across from A and angle B is across from side B, your triangle is correct, the way you drew it. Okay, so I need to find the missing angle first. So let's find angle B. So I want angle B, and I put it over its side, and then I have sine of 50 degrees over 16. Multiply both sides by 10. You should get sine of B is equal to 0.478778. This is less than 1, so it's good so far. We need to test when we put the angle in here if it makes sense. So now we're going to do the inverse of that. So inverse sine, this is what you're typing in. And it's 0.61 degrees. Okay, so far, is this triangle okay? Yep, it's less than 180, so we have room for a third angle. So that means we do have a triangle. So let's check, before I finish this, let's check and see if there's a second triangle in here. So guys, if I were to swing this 16 this way, that means this side is also 16. This creates an isosceles triangle. This is 16 and this is 16. This is 28.61 and this side is 28.61. This is on a straight line. That means this side of the angle and this side of the angle have to add up to 180. So in your calculator, do 180 degrees minus 28.61 to find this obtuse angle in here. I get 151.39. So guys, this is the triangle I'm looking at right here. I'm trying to see if this second triangle is possible. So let me just draw it larger right here so you can see. This is 16, this is 10, this is the 50 degrees. That did not change. However, I just found out that this obtuse angle would be 151.39. Is that possible? Whoops. Is that possible? Why isn't it possible?
Because it's more than 180.
Yep, it's already more than 180. I don't have space for another angle. So that means this second triangle is not possible. So guys, we only have one triangle, okay? So guys, once you confirm that this first triangle works, go ahead and check if there is a second triangle. That's step 2. So we found the supplementary angle. Supplementary angles add up to 180. So we found what the supplementary angle was. This is the supplementary angle. And this supplementary angle, 151, was too big to make this triangle possible. Okay? So there are not 2 triangles. There's only one. So let's go back. We're gonna go ahead and solve for that first triangle. Let's finish finding the next angle. So we're gonna do 180 minus 50 minus 28.61. So this is 101.4 degrees. Or actually, let's just put 39. I won't round it. 101.39 degrees. Okay, now all you need to do is find side C. So we want side C, so you put it over its angle, equals this pair, so I'll put 16 in the numerator and the angle in the denominator. The ratios need to match. So if your angle is in the denominator here, it needs to be in the denominator here. Now, you just multiply both sides by sine 101. Those cancel. Multiply this side by sine 101.39. So this is what we're typing into the calculator. And side C is 20.48 inches. So we know all the sides of the triangle and all the angles of the triangle. And there's only one triangle in this scenario, okay? Let's do the last example. All right, so let's go ahead and draw this triangle. I'll say angle A is here, and it's 35 degrees. Across from angle 35 is side A, which is 7. And I'll call this side B, and angle B. Okay, so let's go ahead and see if we have a triangle or not. So the first step, you need to find this missing angle. So I want to find angle B, so sine of that angle over its side is equal to this pair that we already have. So sine of 35 degrees over 7. So we're going to solve for angle B. Multiply both sides by 10. All right, so this is what we're going to type in. You get sine of B is equal to 0.819395. And this is less than 1, so it's okay so far. We might have a triangle. Let's find the angle, and we get 55 degrees. So angle B is 55 degrees. And that's okay. This is less than 180. We have room for a third angle. So that means we do have a triangle. Now, before we move on, let's just check and see if there's a second triangle in here. I am going to swing, because this angle is not determined. They didn't tell us that in the beginning. I can swing this angle this way. This is 7 and this is 7. I swung this leg over here. Now, if this is 7, then this is 7. If this is 55, then this is 55, right here. Okay, this is what I'm looking at. That means if this is 55, 180 minus 55, get 125. So let's look at this triangle in here. Let's see if this is possible. This one, that's 10, 7, this is 35 degrees, that's given, and we just found out that this angle in here is 125. Is that okay? Yep, that's okay. So guys, we have a second triangle. If this is 35 and this is 125, that means this angle, that one's 20 degrees, because 125 plus 35 plus 20 is 180. Okay, so we have two triangles. So that means we need to solve this one, and we need to solve the original one, okay? So let me clean this picture up a bit. So let's finish finding this one. 180 minus 35 minus 55. This is a 90-degree angle, okay? Now let's find side C. So if I want side C, that goes in the numerator, over its angle is equal to 7 over sine of 35 degrees. Okay. That side is 12.2 long. So we solved the triangle, the first triangle. We found all the angles and all the sides. So your first triangle is done. Now we need to worry about the second triangle. So I just need this last side right here. So I'll put C over its angle, and I'm gonna call this one A prime, B prime, and C prime, just to distinguish this one, okay? So side C goes with sine of 20 degrees, and I have 7 over sine of 35, this pair right here. Okay, so now I'm going to multiply both sides by sine 20, and we'll find you get this other side right here, C prime, is equal to 4.17. So that's how long this side is. Okay, so we found the sides of the second triangle and the angles of it, and we solved the first triangle. So there were two triangles in this scenario. So guys, we found when there was no triangle, one triangle, and two triangles. And let's review the steps. Step 1, you always find the missing angle. And then after that, you want to swing that other leg over and see if this supplementary angle here would work. Because if this angle is 28, then this angle right here is 28. So then you can find this supplementary angle. And then ask yourself, does that triangle make sense? That's how you can tell if there's one or two triangles or not.